lesson 4 or 5. And these are our last graphs of our the chapter 2. Actually, no, we're graphing on our calculator for 4-6. That's next week. All right, so let's do, we're going to do tangent, cotangent, cosecant, and secant. So here we go. Let's go ahead and let's graph y equals tan x. All right, so tangent, as you know, tangent on the unit circle, right? If you go around the unit circle, and if I asked you to evaluate the tangent of 0, you would look at the y value over the x value, correct? Y over x. So in this case, at 0, this is the point 1, 0. So y over x would be 0. Okay. At pi over 2, though, we end up having a problem here. This is the point 0, 1. And when we evaluate the tangent of pi over 2, we get 1 over 0, which is what? Undefined. And so that's where our asymptotes are going to be. Our asymptotes are going to be wherever cosine equals 0. Okay, so look, tangent is the y value over the x value. So tangent, we can say, is sine, oops, hold on. Let me rewrite that. Back up. Tangent of x is sine x over cosine x. And so whenever cosine equals 0, that's where we get our asymptotes out. Okay? All right, so let's go ahead and let's graph tangent, and then we'll talk about all the different properties that tangent has. Okay? So here's the graph y equals tan x. Go ahead and draw your basic trig graph. Okay? And so where cosine is 0, that's where my asymptotes are going to go. And so my first asymptote would be at pi over 2. Okay. The next asymptote is going to be at 3 pi over 2. Because when I get to pi, that's where we get 0. But when I go to 3 pi over 2, then I get another asymptote here. Okay. Over on the other side, if I go this direction, at negative pi over 2, I get an asymptote. And then at negative 3 pi over 2, we get an asymptote. All right, so that's everywhere cosine is equal to 0. And if you can picture this, like picture the cosine graph going through all of this, right? Hit 0 here, hit 0 there. Do you see that? Everywhere cosine hits 0, that's where your asymptotes are. Okay, I'm going to take that off. All right, so now let's go ahead and see what tangent looks like. So tangent is 0 right there at the origin, just like sine, 0. Okay? At this point right here, this is pi over 4. Do you remember what tangent is equal to at pi over 4? Does anyone remember? On the unit circle? 1. Remember, it's rad 2 over 2 over rad 2 over 2. So this is equal to 1 right here. Okay, at negative pi over 4, it's equal to negative 1, because that's in quadrant 4. And then this is what the graph would look like. It's going to hug right along the asymptote and curve kind of like a cubic function, like that. Okay, so that's one period of tangent. And then you're going to draw a couple more. Okay, so like this, just to show that it continues, like that. Okay, so there you go. That's the tangent graph. So let's talk about some characteristics here. If you look at one full period of tangent, that would be just like this one in the middle. Goes through the origin, has asymptotes at negative pi over 2 and pi over 2. Well, how long is that? What's the period there? You know how sine, it goes through the whole thing and it takes 2 pi to do that? And cosine also, it takes 2 pi. How long did it take for tangent to do one period? Just 1 pi. Just pi. So the period of tangent is pi. Okay. Of course, we're going to shrink that, and stretch it, and do all kinds of fun stuff with it. But basic basic tangent, period's pi. Tangent has no amplitude. Because remember, amplitude was how high it was going from its center. Okay? Tangent just keeps going forever in each direction. So we can't say that it has an amplitude. Let's talk about the domain and range. Domain is tricky because it's not a continuous function. So there's going to be points of discontinuity along the way. So the domain would be all real numbers except for pi over 2, 3 pi over 2, ... You can write it like that. You can write plus or minus in front. Okay? The book wrote something like pi over 2 plus or minus n pi. Okay? I don't need you to write all that fancy stuff. Okay? And then the range is easy on this one. The range is all real numbers. Because as you can see, it hits every single y. It goes all the way up and all the way down. All right, so that's tangent. Okay, so let's do some things. We're going to, shift it, reflect it, do all kinds of things. Here's a couple of things that you should know. The period, when we're going to change things here, so we're going to have something like y equals a tangent of bx. Okay? A is going to be a number out front, which is going to stretch it. It's not the amplitude. They do call it A, though, but it's not amplitude. And B is going to change the period. So the period's going to now be, for tangent, pi over B. So cosine and sine, it's 2 pi over B, but for tangent and cotangent, it's going to be pi over B, because it only takes one pi to get through the whole thing. Okay, so that's going to be the period. The asymptotes are going to be, and you can do it this way, plus or minus pi over 2. Okay, so that's your basic asymptotes for tangent, but it's going to be divided by whatever b is. Okay, because b is going to affect the period, it's going to affect the asymptotes too. All right, and that's all you really need to know. So let's go ahead and do some. Here we go. Number 1. Let's do y equals the tangent of x over 2. Y equals tangent x over 2. Okay, so let's first start by finding the period of tangent. Thank you. All right, so the period of tangent is going to be pi divided by b. What's b in this case? 1/2. Good. So you're kind of used to this because we did this, with sine and cosine. So the period is going to be 2 pi. Pi divided by 1/2, 2 pi. All right. So you can think of this in 2 separate ways. If you like to find out what the period is, take the period and split it in half. Okay? Because I'm going to go in this direction, half the period, and in this direction, the other half of the period. Okay? So now you can find out where your asymptotes are. So where are asymptotes going to be in this problem? At, anybody know? Pi. And negative pi. Because doesn't that make 2 pi all the way across? Yeah. And so draw your asymptotes in. How do we know that?
Yeah. Like, how do we get
Okay, yeah. So up here, this is basic tangent. So tangent's going to go through the origin, and it's going to have asymptotes at pi over 2 and negative pi over 2, and that makes an entire period of pi all the way across. But now the period changed in this one, and so the period's now 2 pi. So to make 2 pi all the way across, I got to go to pi and pi now. Yeah. Okay, and then just draw your basic tangent. Nothing's changed. It hasn't been stretched or anything. It just looks like a normal, and I'm not too picky on what it's going to look like. I do need more than that, though, because that looks like it could just be one thing, okay? So you're going to go to pi, 1 pi, 2 pi, 3 pi. Remember, the period is 2 pi, okay? So from 1 pi to 3 pi would give you another graph. And then I need 2 periods of it, of tangent. For sine and cosine, one's good. You go through the thing. But this, and if you wanted to go also on the other side, the left side, you could do that too. Okay? And that's it. And that's how you graph it. That's tangent. If you wanted to, you could memorize, if you don't like it like that, it's a little confusing with taking it half and going each way, you could memorize this too. Hold on. This right here will tell you what the asymptotes are. If I memorize that instead, I do pi over 2 divided by 1/2. I flip it, and I get that the asymptotes are at plus or minus pi. That's another way to do it. Okay? Yeah?
Wait, why would it be pi to 2 pi for the, like,
How far is pi to 2 pi? 1 pi. How much is a period?
Okay.
2 pi. Yeah. So that's the other thing that people will do on this is they'll think that it's the next tick mark is the asymptote, but it's not. Okay? Remember, there's a point in the middle. That's a tick mark right here. And then on either side of it are the asymptotes. Okay? So when you go to here, you got to do a tick mark. That's going to be the middle, and then an asymptote. All right, let's do some more. Number 2. Let's do y equals -3 tangent of 2x. All right, I've changed a couple of things now for you. A couple of things, okay? So first, let's go ahead and find the period. The period's going to be pi over 2, which means my asymptotes are going to be half of that. Okay, so you split it so that they're on either side of the origin. And so my asymptotes are going to be here and here. So this would be pi over 4 and negative pi over 4. And I need to see those. I need to see where the asymptotes are. Okay, so there's an asymptote, and there's an asymptote. And then I would do another tick. That's another pi over 4 and another pi over 4. And I need you to label that one too. What's that one going to be? This is 1 pi over 4, 2 pi over 4. That would be 3 pi over 4. Okay, so we can see the asymptotes. All right, now let's talk about what this -3 is going to do. So when I go ahead and graph this, tangent is going to go through the origin. And normally, halfway between here and here, I would be at 1. That's the normal tangent. That's like the pi over 4 is at 1, okay? But it's like, it's been shifted and stuff. Or not shifted, but shrunk. Here, I have to go to -3, halfway between, okay? So I'd go 1, 2, 3. This is going to be my point. And then halfway between, I'm up here at 1, 2, +3. And so what this does is this really stretches it like that, and it also flips it to go the other way. Did you notice that? Yeah. Normal tangent looks like a basic cubic. This gets flipped to go like a negative cubic, and it also stretches it. Because a normal tangent should be like this. This red one right here. Like that and like that. That would be a normal negative tangent, but that 3 makes it stretch all the way up. So instead of this point being at, halfway between at 1, I'm up here at 3 instead. Okay? And then you just graph, a few of them. You get the idea like that. Just graph. You can graph a couple more if you want to, but that's pretty good. Whew, any questions? Yeah?
So you only show points for that first one, and then the rest of them you just like sketch?
Yeah, you can just sketch it. Yep. So that's not too bad, right? You want to try one? Sure you do. Number 3. You try this one. Y equals 4 tangent of pi x. Really messed with you there, didn't I? Do you want me to do this one with you? Some of you got this. That's a little tough. It's a little tough. Okay, so let's find out where our asymptotes are and all that good stuff. So the first thing you want to do is find out what the period is. And the period's going to be pi over pi, which is 1. 1, okay? So the period's 1. That means one whole tangent's going to fit in a cycle of 1. So that would be, you would need to go which way in each direction? Yes. So I'd go to -1/2 and +1/2. Okay, it's okay to label your scales differently every single time. And those would be the asymptotes, okay, through those points right there. All right, so I'd go 1/2. Another 1/2 would be at 1. Another 1/2 would be at 3/2. So make sure we have a distance of 1 between each period of tangent. All right, we're ready? Let's do it? Okay. So tangent goes through the origin, and then halfway through, we're going to be 1, 2, 3, up here at 4. So we really get stretched out here. And then here, we're down here at -4. So here it is. There it is. Okay? And then the other one, you're just going to kind of mimic it, stretch it out a little bit. There you go. Question? You thinking?
So why did you move over? Like, why did you put that second tick mark in the middle one?
This one?
No, the other one. Yeah,
This?
right there.
Oh, because in between here and here is going to be halfway. Normally that halfway button or halfway point is 1, but I'm up here at 4 at that halfway part. So on regular tangent, the halfway mark is right here at pi/4. That's where we're equal to 1. So halfway from this point to the first asymptote, you're normally at 1. If there's a number out front here, that's going to make it stretch at that point. It's like multiplying 4 times 1 and getting 4 instead. All right, let's do now number 4. One more of these, and then we'll move on to cotangent. Let's do a shift. You want to do a shift? Shifts are terrible with tangent and cotangent. All right, let's do y equals tangent of x minus pi/4 plus 2. Y equals tangent x minus pi/4 plus 2. Okay, so you know your shifts, right? We know this is going to shift pi/4 to the right, and we also know that we need to go up 2. The period does not change. The period is pi/b. B is 1 in this case, so the period's still pi. All right, shifting asymptotes is tough. All right, so let's look at this. Here we go. Draw your graph. First of all, we're going to shift up 2, so I kind of like to draw, a pretend line there, because that's going to be my new x-axis in a way. All right, and then normally I would be right here at pi/2 and at -pi/2. It's kind of gross. Those would be my asymptotes. But I need to shift everything pi/4 to the right. All right, so let's find out where pi/4 is. So here's pi/4. Okay, so there's pi/2, and this would be pi. And then halfway between, look at all these tick marks now. It's bad, isn't it? And then I also need one here, and I've got one there. Okay? Do you see all those tick marks? They're really bad, aren't they? Yeah. All right, so let's go ahead. And so normally I would be here at pi/2. I need to shift that to pi/4. So don't draw that in. I'm actually going to erase that because I don't want a bunch of lines on here. So that asymptote is going to go right there. Okay? My other asymptote, which goes through pi/2, is also going to get shifted pi/4 to the right. Is that pi/4 to the right? Yes. Yes. There you go. Okay? The period's still pi in here, right? We're still in pi? Okay, we got to find the center of this thing. We've got 1, 2, 3, 4. Is the center like here? Am I off? I'm off, huh? It's right here, huh? Yeah, it's at pi/4. I knew I felt like I was off. Yeah, because you're at the origin. If you go pi/4 to the right, you should be at pi/4. Okay, but we need to be up 1. Up 2. We're right here. That's our point. Okay, we're ready to graph. You're like, what? So halfway between, we got to be at 1, and then halfway between here and our asymptote, we would be right here. So there's our tangent graph. Wow. You got that? Yeah? I barely got that. And then I'd have to graph another one? Really? You're like, yeah. Okay, I'd go over there somewhere, and I would graph another one. I'd probably need to label that. That's not too bad to label. What would that line be right there? Normally this is what? 3 pi over 2? This right here, our normal asymptote, 3 pi over 2. You would just need to add a pi over 4 to that. Okay? Which you need to get, a common denominator. So this would be 6 pi over 4. So this would be 7 pi over 4 is that asymptote right there. Terrible. So shifting, moral of the story is shifting cotangent or tangent, and you'll see cotangent, is really tough. You have to shift like all those asymptotes over. It's not as much fun as sine and cosine. All right, are you ready for cotangent now? Sure you are. Okay, let's do cotangent now. All right, y equals cotangent of x. Now remember, cotangent on the unit circle is flipped, right? Tangent flipped, bless you. Instead of it being sine over cosine, cotangent of x is cosine over sine. So we're looking at wherever sine is equal to 0, that's where our asymptotes are going to be for cotangent. So they're different. So tangent was at negative pi over 2 and pi over 2. Cotangent is going to be a lot different than that. So here are the asymptotes for cotangent. Asymptotes for cotangent are at 0, because you know that pi goes through, or sine goes through 0 right there at the origin. So we have 1, 2, 3. And then this would be pi. You can go that way. Let's go this way. And that would be negative pi. Okay? So my asymptotes for cotangent are going to be at negative pi, 0, and pi. I mean, picture the graph of sine, right? Sine looks like this. So when sine equals 0, that's where I need my asymptotes for cotangent to go. So if you ever forget that, you could always graph the sine wave. All right, and then cotangent is going to have points right here at pi over 2 and negative pi over 2. And cotangent is going to be like tangent, but flipped the other direction. Looks like a negative tangent. So it's going to go like this. Okay? And then 1 over here, too. You can draw a whole bunch of them. That's fine. So then let's talk about all of the different things about cotangent now. Cotangent and tangent are very similar. Their period is going to be the same. Regular period's pi. If we change it, it's going to be pi over b. Okay? But cotangent does not go through the origin. All right? So its asymptotes, the asymptotes are going to be at 0 plus or minus pi over b. Okay, so 0 is going to be an asymptote for cotangent. And I think that's actually easier. Because when you find out what the period is, all you do is go that way to the right and that way to the left, and those are your asymptotes. All right, so let's do a couple of these. Here we go. Number 5. Number 5. And these are the 2 hardest graphs of today. The next 2 are going to be really easy for you. Okay. No, I'm serious. Y equals 2 cotangent of x over 3. Y equals 2 cotangent x over 3. All right, so here we go. The period is going to be pi over b, and b is 1/3. So our period is going to be 3 pi. You're like, ew, that's gross. It's not that bad, though, with cotangent. So let me show you cotangent. You're actually going to like it. Cotangent has an asymptote through the origin. And then if I need a period of 3 pi in each direction, guess what I go? I go 3 pi to here, and I go negative 3 pi to there. Isn't that so nice? I know. It's a little bit better because with tangent, you know how it has the dot at the origin, so you have to go half and half? This, you don't. You go this way and that way, and there's 2 of them for you. Okay? So now you go halfway in the middle of it, which would be 1.5 pi or 3 pi over 2. And then you're going to put your dot there. This is 2. So halfway between, we're going to be up at 2. And then halfway between here, we're going to be down at -2. So it gets stretched a little bit. And that would be the graph there. And then you just mimic it over here. There you go. Cotangent. Is that, you wanted to try one? Sure, no problem. All right, you try this one. Number 6. Should I throw in a bunch of stuff for you?
No.
Yes? No? Y equals negative cotangent of 2x. How's that? Just 2 things, okay? All right, try this one by yourself. I'm going to pause it. Oopsie, catch up to speed. All right, period is pi over 2. We're going to draw, I do that all the time. We're going to draw an asymptote there, and then we're going to go over here to pi over 2 and draw an asymptote, and then negative pi over 2. So far, so good? Yes, that's all you got. Okay, so now let's draw cotangent. And we're going to go halfway between, so that's at pi over 4. We're going to put a dot. And then this is 1. And halfway, we're usually over here. But because there's a negative, it's going to get flipped the other direction. It's going to look like tangent instead. And so it's going to go like that. Like that. Ooh, very wobbly. And then you can draw another one over here. Okay? So that's what it's going to look like. Yes? Who got that? Oh, good. A few of you. Nice. Okay. All right. Do you feel okay about cotangent tangent? Let's move on. All right. No. Yes, we do have practice on Friday, and you have homework practice to do, and I can help you with that if you want to get close to me. All right. Letter C. I don't know. I don't think it's the flu. I think it was just food poisoning. Okay. Let's do our graphs of cosecant and secant. Y equals cosecant x, y equals secant x. Now, let me show you the graphs of these. Now, cosecant and secant are also undefined because, as you know, cosecant is 1 over sine and secant is 1 over cosine. So wherever sine is 0, here we're going to have asymptotes. Wherever cosine is 0, here we're going to have asymptotes. You're like, great, more asymptotes to figure out? These aren't as bad, though. Okay? Let me show you on your graph what it looks like. 1 over sine of x, and I graph that, and they look like little parabolas, huh? See that?
Oh, I don't like that.
No, they're not bad. Okay, so, no. Do you like graphing sine? Like, sines become, maybe not like, that's a harsh word, but like, like, yeah, it's an extreme word for math, it is. But yeah, but if you like graphing sine, that's all you're going to do. You're going to graph sine, and then you're going to turn it out. You ready? I'll show you. So here's the graph of y equals cosecant x. I go to my graph here, and it's going to have the same period, doesn't really have an amplitude. We're going to talk about that. But we're going to go 1, 2, 3, 4. There's 2 pi. There's pi. And then here's +1, and here's -1. Okay? All right. And what I'm going to do is I'm going to graph sine. And you're like, what? No, we're not graphing sine. Okay, but I'm going to graph it to help me. So here we go. Okay? Here it is. And I'm just going to kind of just barely graph it in. It's not part of my graph, but it's there to help me. Okay? So I barely graph it in, and then what I do is every time sine hits 0, I draw an asymptote there. So there's an asymptote there, there's an asymptote there, and there's one there. And then you know what we do? We turn it out. We take this tippy top point, and we go like this, like a parabola. And I take this little bottom point down here, and I turn it out. There you go. That's one full period of cosecant. It keeps going. Okay, I hope you know that. It will go up here, and then it goes down here, and it goes down here, and okay, just keeps going. But one full period's good. If you got that, you're doing great. Okay? Not too bad, huh? So graph sine, and then just flip it out. All right, secant's the same way. Secant's the same way, all right? We're going to graph cosine, but then flip it out. So you go 1, 2, 3, 4. You go to whatever period it is. This is just your basic graph, okay? You go to whatever the amplitude is for your cosine or sine, and you're going to start your graph there. And you're going to do your normal graph. That's why it's so important to have a good, a good basis of sine and cosine. It's really important that you know those pretty well. I would probably even go over this way to there. And then wherever it touches the x-axis here, you're going to draw your asymptotes in. There you go. And then you just go ahead and flip it out. So the black part that I drew is really the only part of the graph. Everything else was there to help me draw it. Kind of like when we drew hyperbolas, we drew that box in with the lines that went through it, and then we flipped it out. Yeah. Yeah, remember those? That box and all that was just there to help us graph it. All right, bless you. Okay, so let's do a couple, and then we're going to be done. So what are we on, number 7? Number 7. All right, so let's graph y equals 4 cosecant of 2x and then plus 1. All right. I made 3 things happen here that are different than our normal graph. So if we're going to instead, what I do is I think in my mind, I'm thinking y equals 4 sine of 2x plus 1. That's what I graph instead. Okay? I do. All right, so here we go. First of all, let's find the period. Period's 2 pi over 2. So the period would be pi. So we're going to go ahead and graph that. We'll go 1, 2, 3, 4. There's pi, and there's pi over 2. And then I also want to go and shift 1, up 1. Okay? And I'm going to draw that in, and that's going to be like my new x-axis. And I'm going to go 4 above that, 1, 2, 3, 4, so that I'm at 5. And 4 below. 1, 2, 3, 4. So I'm at negative 3. Okay? And then I graph normal sine. Don't actually, like really graph it. I like to just put little dots, maybe. You don't even have to graph the whole thing. Do you see the dots? You don't really need all the stuff in between. If you want to just do the dots, that's fine. And then wherever those dots hit that new x-axis that's at 1, that's where you're going to draw your asymptotes. So there's one there, there's one there, and there's one there. And then do you see those other green dots that I have? That's going to be where the graph's going to go like that and like this. Okay? And that's one full period. And then it keeps going. Keeps going that way. And then the other way, too. Let's talk about domain and range on this thing. Do you want to or no? No. Domain, okay? It's not a continuous function, so it's going to be all reals except for some parts, right? So in this case, domain all reals except for at 0, pi over 2, pi. You can go dot, dot, dot. You can put a plus or minus there if you want to, okay? So add all the asymptotes for this one. And then the range is going to be, well, this graph goes from negative infinity to negative 3. So negative infinity to negative 3. And then it picks up again at the top, 5 to infinity. So that would be the range. Okay? Do we want one more? Should we do a secant now and then call it a day? Yeah. All right, let's do a secant now. Last one, number 8. See how these aren't so bad? Yeah, it doesn't feel like you really learned anything new on those if you just remember to flip them out. Let's do, I don't know, y equals, let's put a negative in there, a negative 2 secant of x minus pi over 2. Don't you hate shifts left and right? I do too. I really do. They're hard. I don't mind up and down. That's not so bad. I don't mind a period change, amplitude change. I don't mind any of that, but the left and right shifts, oof. All right, here we go. Okay, the period didn't change though, right? Period's still 2 pi. We'll go 1, 2, 3, 4. There's 2 pi. Here's pi. I'm going to put the pi over 2's in because we're going to need them for this problem. And then we're also going to need that one too over there. Okay. So 1, 2, and -1, -2. So my cosine, if I were going to graph it normal with the -2, I would be starting right here where this green dot is. Do you all agree? Yes. Okay. But we're going to shift it pi over 2 to the right. I'm going to get rid of that one. Shift it pi over 2 to the right. All right. Everything else should be okay from there. So my next tick mark, I'm back at 0. Then I'm up here at 2. Then I'm back at 0. And back down here at -2. And you could, if you wanted to, continue this way, which might be better. And then wherever it hits that x-axis, that's going to be where your asymptotes are. Okay? And then those peaks right there, that's going to be where your graph gets turned out. I'm going to do another one over there just for fun. There you go. Okay.